Hi, welcome to Dr. Pat TV. This is the second video on compound interest. Remember that compound interest, we're earning interest on our interest. So it's an interesting topic. Bad joke, I know. Sorry. Okay, let's get to the idea. I want to do a little comparison between compound and simple just to kind of really set the stage here so that later on when you've got a test or something like that and somebody doesn't tell you, is it simple or is it compounding, we can start making those makes the distinction between the two so that we can get a good understanding. All right. Basically, what I've got here is a situation. We got $1,000 that we're going to put into an account. Our interest rate is 10%, and we're going to do it for 20 years. And we want to compare simple versus compounding. And actually, there's a third option. You could just put it in your mattress and not earn any interest. And that's what the blue represents there. Is basically put it in your mattress. You're going to have your $1,000 after 20 years. Exactly the same thing as you started with. But if you do it into an account that pays simple interest, that's a linear situation because it's a straight line like this. That's a linear situation. Why? Is because the interest is always calculated on the original $1,000. So even though it's year 14, guess what? We're still going to calculate it on $1,000. Even though you probably have like 2,400, you've got more money in the account, they're still going to go back to the original amount that you put in. So that's why they call it nice and simple, because you're always calculating it on one number. It doesn't change. So it's a very straightforward calculation, a simple calculation. The fun starts happening when you start doing compounding, because now we're earning interest on our interest. And so that's an exponential situation because the amount of interest that we earn each month or that we receive each month is different. It changes. Linear is always the same. Exponential, the amount is changing. And so that's why you get this nice curve, because when things are not changing the same way, it changes differently, you get a curve in your graph. And that's an exponential graph. And so it's a nice way because as you can clearly see from this graph, we earn a lot more money if we put it into the account that compounds. All right, so there's also a difference in the formulas. For the first formula on top here, that's simple interest, and on the bottom here, that's compound interest. And basically, really the difference right here that we're seeing is where the placement of the n. The interest rate is the same, but it's where the n is. And so in the first example, in simple interest, the n is multiplying here, which creates a linear situation because you got a power 1. It's nice and multiplying. But down on the bottom here, our n is in the power. That creates the exponential because the n is in the exponent. And so that's really your key difference here, is where that n is placed in the formula. Is it straightforward multiplication or a power? Now let's get an example. Okay, so we want to deposit $2,500 into an account that pays 2.4% compounded monthly. What's the balance in 2 years if no withdrawals are made? And so I want to bring your attention to something here that's going to make a difference between just your compounding situations and annuities later on. So I'm just taking a moment here because I know something's going to happen later on in when you start studying annuities. Basically, we're looking at a compounding situation. Why? Because there's no withdrawals and we're compounding monthly. So that's kind of the key words. So we're going to earn interest on our interest, but we're not taking in withdrawals. The reason here is if I took out my interest each month, I would actually create a simple interest. Simple interest is always calculated the interest on the amount that you put in. You could set up your account that way, or each month take out your interest and you'd create by that way a simple interest. So that's why with no withdrawals, I'm thinking compounding. And so we have our initial amount, our present value, how much we put in. That's also called principal. We also have our rates in the time frame. Remember that our rates, 2.4%, are given annually. It's assumed an annual rate unless specified otherwise. And our compounded monthly just tells us when we're going to calculate our interest. Each month we're going to calculate our interest and add the interest to the balance. And then we want to know 2 years, 2-year time. Okay, so now in our calculation, these two informations, the 2.4% and the compounded monthly, I need to do a fraction of that because my interest per period, the interest rate per period, would be not the 2.4% because that's an annual. I need to get it into a monthly rate, and that's taking that 2.4, dividing it by 12, for the 12 months. And so basically we're looking at each month compounding 0.002. That's the number that we'd use. So it's really 0.2%, but in our calculations of the formula, 0.002. And then with the 2-year period of time and the compounded monthly, those together would give us a total number of periods of 24. So that's our end value, the total number of periods, how many times we compound. If we're doing it monthly for 2 years, that's 2 times 12 for our 24. Now we have all our information. We can put it into our nice straightforward compounding formula. Present value times this parentheses 1 plus I. Remember, that's the interest rate per period, and we're adding our interest, and we're going to add it to the previous balance, so that's why that 1 is there. And when we do that calculation, we plug our numbers in, we would get 2622.80. So basically we're earning $122.80 in interest over that 2-year period of time. And so to find your interest, just take the difference between what you put in, what you started with, and what you ended up with. So the difference between future value and present value will help you calculate what your interest is. And so we have another formula for compounding, and that would be just a modification of it. Remember that in the previous example, we calculated the interest rate per period per the month. How did we do that? We did a fraction. I did the percentage rate that was given divided by, in this case, the months or the time periods, the compounding periods per year. And so then how did we calculate the total number of periods? We did 12 times 2 in that previous example. And so in our formula, 2 years would be the T, and then again 12 months per year. And so this would be a general formula that you can use for your different compoundings. Whereas the one on top, this one's good for almost any situations, as long as you know that you're calculating the interest per period and the number of periods on the side. So let's take a look at an example of how we can use this formula. We got a certificate of deposit, which is basically an agreement with a bank or lending or any kind of financial institution where we're going to put our money in and we're agreeing we're not going to touch it. So we're going to put $500 for 5 years. I'm not going to touch this $500 or the interest for 5 years. That's the agreement. And then they're going to pay me 2.75% compounded daily. And so what's happening is they like these certificate of deposits because we're guaranteeing that they can use my money for that period of time. Banks can count on it, and then they can make appropriate investments themselves. And so our questions are, what balance do we have when the CD matures, basically at the end of the time period given, which is 5 years here, and how much interest was earned? So we've got 500 is our PV, 5-year period of time. We've got a rate of 2.75%, and we're compounded daily. So basically P would be 500, T would be 5, the R would be 0.0275, and then compounded daily, M would be 360. And our goal is to find the future value in 5 years. And so here's our formula that we'd have. So I put in my rate. I'm using 360 as a standard thing for banks and lending institutions for the year, number of days in the year. And then just plug the numbers in, crunched it out, calculated, and I got something like 573.70 cents. How much interest did we earn? Just the difference between these two values here. So it looks like we earned an interest of 73.70. Okay, I hope this helped. Talk to you later.